transfers gravity load from the top of the building down to the foundation.
But the core doesn't work alone. The designers realized that it would require additional structural stiffening, and the solution came from one of the oldest and most dramatic architectural features in history: the flying buttress. Flying buttresses give lateral support to medieval churches from the outside. But Dane and his team hid their lateral supports inside the tower. Huge girders called outriggers connect the central core to a series of columns that run around the building perimeter.
I'm now at level 28. Level 28 is a mechanical level, and we can actually see some of the massive outrigger elements. These outrigger elements are 5 foot 6 inches thick, 17 feet deep, and run from the central core of the building all the way to the perimeter columns.
These giant outriggers require one of the strongest concrete mixes in the world.
A typical concrete would be 3,000 or 4,000 pound per square inch compressive strength. We specified up to 16,000 PSI concrete, which was really pushing the limits of concrete technology.
16,000 PSI is the same pressure that's felt at the deepest part of the Earth's ocean, at the Mariana Trench, nearly 7 miles deep. But to make such a record-breaking mixture, Dane needed the specialists to push the chemistry of concrete into new territory. From their high-tech control rooms, technicians at the concrete specialists in Chicago designed 4 top-secret and brand-new mixes. And for the tower's outriggers, one of the strongest ever made. The key is in the mixing agents, and the quantities and the combinations are strict trade secrets. But having designed a structure built with a material that could provide unparalleled strength and stiffness, the construction workers faced a problem no one had ever had to deal with before: how to get tons of freshly mixed concrete up an ever-increasingly tall tower before it's set. Faced with finding a solution was construction manager Brett Szabo.
First started looking at Trump Tower. We had to start investigating how are we going to pump it up there. I mean, physics, the higher you go, the harder it gets. You have to push it higher, you need more force.
The traditional method of getting concrete up high is to hoist it up in buckets. But with the tower relying on unprecedented quantities of concrete, the traditional technique was simply not fast enough. So Brett had to find another way.
So this is the concrete pump that we use at Trump Tower. So this is what pumps the concrete all the way up to the top from the ground level where we put the concrete in.
The pump they used was the most powerful in the world. At 680 horsepower, nearly as much as a Formula One racing car, this machine enabled engineers to force 6,000 pounds of concrete per minute through 1,700 feet of piping. And the concrete structure brought an added benefit. Using 720 million pounds of high-strength concrete meant that the architects could plan for thinner floors and unobstructed exterior walls, giving unrivaled space and amazing views to the tower's residents.
So this is a typical guest room. One of the advantages we have in designing in concrete is that we're able to achieve a floor-to-ceiling height of 10 feet, but yet your floor-to-floor height is much more diminished. So we're able to get many more floors than the overall height that we have.
But 10-foot windows adds up to a lot of glass. Bad news for a building in the firing line of killer twisters.
I mean, it's very possible if the tornado is strong enough and you're near a window, it shatters, that you could be literally pulled right out of a building.
The Trump Tower gleams on the bank of the Chicago River. covered in 680,000 square feet of glass, enough to cover almost 12 football fields. It gives every guest and resident stunning floor-to-ceiling views of Chicago and Lake Michigan. But this is Tornado Alley, and sooner or later, downtown Chicago could be hit by an F5 tornado with wind speeds up to 300 miles per hour. In November 2013, a series of deadly twisters, including an F4, struck Illinois, flattening homes. And if the tower's glass windows give way to a tornado raging at full throttle, for people inside the building, it could be the stuff of nightmares.
It's very possible if the tornado is strong enough and you're near a window, it shatters, that you could be literally pulled right out of a building.
Yeah, huge implications to the public. You know, anything, especially when you build this tall, you don't want pieces or components of the building falling off into the general public.
300-mile-an-hour winds push and pull on each window with 25,000 pounds of force. And unless they're rigidly secured, that's more than enough to tear them off the face of the building. To prevent this from happening, the exterior, or curtain wall, was designed to secure the glass windows from oncoming wind. In order to safeguard the glass from being wrenched from the building, each panel was manufactured inside an aluminium frame. These frames were then secured to the concrete superstructure, dispersing the powerful wind forces away from the glass and into the stronger structure behind it. It's an ingenious system. But before putting into practice on the building, Lucas had to be sure that the glass windows and their innovative frames would keep the occupants dry and draft-free.
You know, we have 11,000 panels. If you get it wrong, that's times 11,000 problems that you have.
The glass was put to the test at a site in Miami under the watchful eye of Chief Engineer George Dotzler. For more than 40 years, George's laboratory has simulated some of the worst possible weather conditions to test the curtain walls of world-famous buildings. Today, they're doing what's called the dynamic water infiltration test, checking resistance to a combination of heavy rain and high winds. George and his team unleash nature's worst on a 2-story section of the framed glass panels.
We have these 2 large Pratt & Whitney R2800 engines. We put them in front of the wall with a spray rack behind it, and we run it for 15 minutes. That's a dynamic water infiltration test.
During the test, highly trained engineers carefully monitor the efficiency of the glass panels. If the glass frames deform or even a drop of water seeps through, the curtain wall fails and has to be redesigned.
Sometimes it's something as simple as the hardness of a gasket or the size of the bulb of the gasket. Little things like this can lead to huge consequences for air leakage or water leakage.
This curtain wall sample passes the test. But making the cladding safe is not just about testing. Once Trump Tower's windows had been proven safe, 11,000 specially designed wind and rainproof panels had to be installed by hand. But the windows coming loose from wind force is only part of the problem.
Whoa.
In tornadoes, one of the greatest threats comes from debris clouds. Huge chunks of cars and buildings can be hurled through the air at fatal speeds. And huge debris clouds have already come close to hitting downtown Chicago. In August 1990, when the Plainfield tornado struck just 40 miles away, Paul Merzlock was too close for comfort.
When I looked off to the northwest where the storms were coming from, it was unbelievable.
As tornado sirens sounded across the city, the F5 tornado tore through homes, schools, and office blocks, battering everything in its 16-mile-long pathway.
There was total devastation. Homes leveled to the foundations, rubble, you couldn't tell which debris belonged to which house.
The Plainfield tornado killed 29 and injured hundreds more.
Emergency crews trying to reach devastated areas were impaired because of debris on those roadways. And yeah, there was quite an impact.
A major tornado could strike again, and downtown Chicago is just as likely to be hit as anywhere. How could the tower's engineers be sure that the 680,000 square feet of glass